This screencast is going to look at measures of central tendency and variability. We will investigate how to check that our data is normally distributed, how to identify outliers within the data, how to generate means, medians and modes, and also measures of variability. Within this dataset, we have data from participants on 5 different variables. If we move to variable view, we can see what type of data each variable is. By scrolling across, we can see that 2 variables, sex and team, are nominal data, age group is ordinal data, and passion and life satisfaction are scales or interval data. Both of these scales are measured on a 1 to 7 range, with higher scores indicating higher levels of the respective variables. The first thing we want to do before running any type of analysis is check that our interval data, so passion and life satisfaction, are normally distributed. We're going to do this using the skewness and kurtosis scores. First, we need to select the Analyze tab in the top menu. Go to Descriptive Statistics and select Frequencies. Within the Frequencies box, we are going to select Passion and Life Satisfaction and move them to the Variables box. Next, we are going to select the Statistics option and tick the boxes under Distribution for Skewness and Kurtosis, and then click Continue. Next, select Charts, and within this menu you want to select Histograms and tick the box to show normal curve on histogram. Finally, click Continue and then OK to run the analysis. On the output, we can see the skewness and kurtosis scores for both passion and life satisfaction. We can also see the standard error of skewness and the standard error of kurtosis for both the variables. It is proposed that when the ratio of the skewness or kurtosis to their respective standard error is above 2, then our data is not normally distributed. As you can see, it seems that for this data, passion is not normally distributed, whereas life satisfaction is. By scrolling down, we can see the frequencies, or the number of participants, who responded to each point on the 1 to 7 scale. As we can see in the frequency table for passion, participants responded to each point of the 7-point scale used. However, there are also 2 participants for which the score is 8. This gives us an indication that we may not have entered the data correctly when putting it into the spreadsheet, and this is something that we need to check when we're entering data. The 8s in this case are what is known as out of range data, so a piece of data which is not possible based on the scale that we've used. We can also see from the frequency table that most of the scores are at the higher end of the scale. There are only 13 scores people who responded to 1 or 2, whereas there are 42 for 6 and 72 for 7. So this gives us an indication that our data might not be normally distributed. When we look at the frequency table for life satisfaction, we can see that there are no out of range values in this variable, and that the data is much more clustered around the middle points of 4 and 5. By scrolling down further, we can see the histograms for each variable. As we can see, the histogram for passion supports the skewness and kurtosis values and the information in the frequency tables that more participants responded to the higher end of the scale. That is, the data is positively skewed towards the higher ends of the scale. We can also see the 2 out of range values of 8, which are most likely due to an error when entering the data. On the other hand, the histogram for life satisfaction shows that the data is much more normally distributed, with the values fitting underneath the normal curve and no out of range values. Now that we've checked the distribution of our data, we now need to check to see if there are any extreme scores or outliers which may be a result of inaccuracy in data entry. To do this, we go to the Analyze menu, again select Descriptive Statistics, and this time select Explore. In the Explore menu, we are going to select Passion and Life Satisfaction and move them to under Dependent List. Next, select the Statistics option and tick the Outliers box. Click Continue to return to the main Explore menu. Next, select Plots. And in this menu, we want to unselect Stem and Leaf and tick the box for normality plots with tests. Click Continue and then OK to run the Explore function. When looking at the output, by scrolling down, we can see in the Extreme Values box any outliers which may be in our data. In the Extreme Values box for Passion, we can see the 5 highest and 5 lowest scores which were given by participants. Within the highest values, we can see that 2 cases, case 11 and case 23, are given a score of 8 in the data. We know this is not possible as our scale was measured from a 1 to 7 range. So we know that we must have made a mistake when entering our data, and that these values are not correct. For life satisfaction, we can see that all of our values, both highest and lowest, fall within the acceptable range which the scale was measured on, that is, a 1 to 7 scale. By scrolling down, we can see the results for other tests of normality, which check the normal distribution of our data. If the significance values for the Kolmogorov-Smirnov or the Shapiro-Wilk tests are below 0.05, this suggests that our data is not normally distributed. In the present example, both the significance values for both tests, for both variables, passion and life satisfaction, are below 0.05. This suggests that our data is not normally distributed. However, these tests are very sensitive to sample size, and so when the sample size is high, they are more likely to produce significant results. Therefore, it may be more appropriate to use the histogram and box plots, which we're going to go on to discuss, to determine if our data is normally distributed. Other tests of normality show us graphically whether our data is normally distributed. With the normal QQ plots, the greater our data is normally distributed, the closer the dots will be clustered around the diagonal line. So we want all the points on the graph to be close to the diagonal line. Here for passion, we can see that not all of the points are that close to the line, again indicating that our data may not be normally distributed. The box plots show the range of 50% of the cases of each variable. The thick line in the middle indicates the median of the variable, and the vertical lines extend to the highest and lowest values, excluding outliers. The circles at the bottom of the chart identify outliers. For passion, the box plot indicates 3 outliers identified with their case number, 36, 53 and 109. As you can see from the normal QQ plot for life satisfaction, the points are all clustered much more closely around the diagonal line. This indicates that life satisfaction is much more normally distributed than passion. Also, there are no outliers identified on the box plot for life satisfaction. Now that we have identified that our data is not normally distributed and that there are outliers within certain variables, we need to decide how to proceed before running our analyses. In our case, we know that the values can only be 1 to 7, as that was the range on which we measured life satisfaction and passion. Therefore, we may want to delete the values of 8, as we know that these are not possible values. In a real data situation, you may want to go back and check the original raw scores to ensure that you have entered the data correctly. If the values identified as outliers were extreme but plausible cases based on our data, or the data is not normally distributed after we've removed out of range values, we may want to consider transforming the data using various transformations such as logarithmic transformation to make the data more normally distributed. So we will delete the value of 8 for case 11 and for case 23, as we know these values cannot be correct. Now that we have checked our data for normality and removed any potential outliers, we can now start running analyses. First, we are going to obtain the measures of central tendency for each variable used. To do this, we go to Analyze, select Descriptive Statistics, and choose Frequencies. In the Frequencies menu, we now want to select all the variables and move them to the Variables box. Once we've done that, we select Statistics, and this time select Mean, Median and Mode. Go to Continue, and then OK to run the analysis. In the output, the mean, median and mode are expressed for each variable. The most appropriate measure of central tendency depends on how the variable was measured. The mode is most often used for nominal data, in our example, sex and team affiliation. The median is most often used with ordinal data or skewed interval ratio data. So in our example, this could be used for age group or passion, as passion is a skewed interval data. The mean is used with interval or ratio data that have a normal distribution, which in our case would be life satisfaction. As well as getting the measures of central tendency, we can also get the measures of variability that are suitable for each variable. To do this, we again go to the Analyze menu. Again, select Descriptive Statistics, and again select Frequencies. As our variables are already underneath the Variables box, we can go straight to Statistics. This time, we want to deselect our measures of central tendency, so mean, median and mode, and select from the dispersion options standard deviation, variance and range. Click Continue and then OK to run the analysis. The output shows the standard deviation, variance and range for all of the variables. As with our measures of central tendency, there are certain measures of variability which are more suitable dependent on what type of variable we have measured. Range is often used with nominal or ordinal data, so this would be appropriate for sex, age group and team. The variance and standard deviation are often used with normally distributed ordinal or ratio data. So in this example, passion and life satisfaction. Even though passion is not normally distributed, we can use variance and standard deviation, although they may not give a fully accurate description of the variability in this data. Now that we have produced the measures of central tendency and the measures of variability for our variables, we may want to display this information in a table. To do this, we go to the Analyze menu, choose Tables, and select Custom Tables. Click OK, and we can now define our table. First, select Sex and move it to the Columns box. Next, select Age Group and move this to the Rows box. Next, we're going to select Life Satisfaction and move this to where it says Count below the Sex column. While Life Satisfaction is still selected, we are going to click on the Summary Statistics box underneath Define. Scroll down on the Statistics menu until you get to Standard Deviation. Click on Standard Deviation and move it into the Display box. Then click on Apply to Selection to return to the Table Design box. Next, click on Sex and then click on the Categories and Totals box. Next, click Total under the Show menu. This will produce descriptive statistics for each age group collapsed across gender. Then click Apply. Next, do the same for age. Again click Total, as this will produce descriptive statistics for each gender group collapsed across age. Then click Apply. Finally, click OK to produce the table. The output displays the means and standard deviations for life satisfaction by gender, so the different values for males and females, and also by age group, so for young males, middle-aged males and old males, and young females, middle-aged females and old females, as well as the totals for all of these categories. This concludes the screencast for measures of central tendency and variability. We have looked at how to check for the distribution and outliers in our data, how to generate means, medians and modes, and also how to generate measures of variability.